Hi there. Welcome to this practice set. This is going to cover the lesson that I titled Laws of Exponents 1. It is a review of a lot of Algebra 1 laws of exponents. So if that's what you're looking for, then this is the place you want to be. If you're looking for some of the more advanced laws that we encounter in Algebra 2, like negative exponents, then you want to check out Laws of Exponents 2, which probably is uploaded by the time that you watch this, unless you are watching this like the very first week I upload it. Please like this video if you find it helpful. Subscribe to the channel for more math help. Ask me a question in the comments, and please check out the many other videos and playlists that are on the channel. As always, pause the video to work these problems on your own, and then come back to check your work. Okay, so we're going to start off fairly tame. With 2x to the fourth power. The most common mistake I see students make with this is they just say it's 2x to the fourth. And both of those are said the same way. We'll say 2x to the fourth. You might hear that top one said 2x all to the fourth power, and the word all, that is all, is used to signify the presence of the parentheses there. Now, you can do this the short way. Okay, and the short way would be to use our property of exponents, which says that you would multiply exponents there. And so this would be 2 to the 1 times 4 is 4, and x to the 1 times 4 is 4. And then you might wonder, do I have to say what 2 to the fourth power is? And there is no hard and fast rule for that. Okay, there is no hard and fast rule for, can I leave it as an exponent? If you had something like 7 to the 15th power, then yeah, you'd leave it as an exponent. Like, we have exponents for a reason. But something like this is probably more comfortable written as a 16. What I usually tell my students is, if it is like less than 4 digits, go ahead and write it out. So anything under 1,000, sometimes I'll even say anything under 100, definitely write it out if whatever it is under 100. But you can go into the triple digits without too much trouble. You might need a calculator to do it. Now, you could also do this one the longer way, where you recognize that this is 2x raised to the fourth power, and then you can see the 4 2's a little bit better if that helps you. All right, next one. Here's what you can't do. You cannot cancel those out, okay? And that should intuitively not feel right, because if you canceled them out and said it was equal to 1, then that would imply you had the same thing in the numerator and denominator, which we clearly do not have the same thing in the numerator and denominator. So for this one, we do want to make sure we are squaring it. So you could do 3x times 3x. Now, if you wanted to cancel one of them out, so 3 over 3 is 1, x over x is 1, that would be okay to do and say I am left with 3x. You could also do something like this, where you simplify it to 9x squared over 3x, and then 9 divided by 3 is 3, and then we do the subtracting of the exponents. 2 minus 1 is 1. So either of those is fine. Okay, I don't know if we're quite in the territory where there's 3 or 4 different ways to do it, but it's certainly more than one way here. Okay, now this one, there really truly are some shortcuts you could take. I will not take a shortcut in my first pass through this. So looking at that numerator, I see that I'm going to be doing 3 times 2, and then x times x squared, and we're going to be dividing that by 6x. 3 times 2 is 6. X times x squared, well, we're going to add exponents, so that's x to the first times x squared, and 1 plus 2 is 3 over 6x. 6 divided by 6 is 1, and then we're going to do the subtract exponents right there, and 3 minus 1 is 2, leaving me with x squared. Now, what I would be more likely to do, okay, I'm going to copy the problem, is this. I would say to myself, X cancels with X. And 3 times 2 is 6, which will cancel with the 6 and jump right to the X squared. I would not show any intermediary work. And that is one of the issues with problems of this type is there's no definitive amount of work that you should show unless your teacher has put really, really specific guidelines in place for you. So you can kind of do, it can be kind of wild. And yes, you can probably get away with cheating, but as always, that's gonna like shooting yourself in the foot. Okay. That is not gonna be a good move for you to make long term. Okay. Now on this one is designed to call your attention to the fact that the 2 is being raised to the 3rd power, but the 3 is not being raised. So what you cannot do is do 3 times 2 and get 6 and then raise that to the 3rd power because the 3 is not being raised to the 3rd power. And so we have to deal with this exponent before we can deal with the multiplication. So that is 3. And then you can do this 2 ways. You can say it's 2x times 2x times 2x, because that's what it is to cube it. Or you could go to 2 to the 3rd power, 3 to the 3rd power. And of course, that's from multiplying that exponent through, which is not distribution, by the way. It looks distributey, but that is not what it is. All right, moving on from here, 2 to the 3rd power is 8. And then 3 times 8 is 24. And you do need to continue to follow the order of the operations. So if you have just the 3 times 2 to the 3rd, that is not 6 to the 3rd power, okay? Because that's your order of operations. Okay, and so exponents come before multiplication. So you've got to do 2 to the 3rd before you do 6 to the 3rd. Somewhere on my channel, I have a video explaining that. I think it's in my number sense playlist. If I can find it, I'll go ahead and link it up here. If you just see the word link up there, it means I couldn't find it, but you can go hunt down my channel for why do exponents come before multiplication in the order of operations. It's kind of interesting to look at. Okay, alrighty. So this one, there are lots of options with number 5 as well. Lots and lots of options. But key idea here is that when you multiply fractions, you do multiply straight across. And so basically we've got a multiplication problem right there and another multiplication problem there. And you can multiply this piecemeal, but there's other ways you can do it. So I will look at it this way first, and then I'll show you what I would probably do more. So looking at the numerator, I have 4 times 6, so that's 24. And then I have x squared times x to the first. And remember, when we multiply like bases, we add the exponents. So x squared times x to the first is x to the third. And then I have the y there. In my denominator, I have the 3, and then I have x times x squared, which we just did in the line 4. That is x to the third. And now I'll do this little trick. I did this in the video too. I am not going to do any math right here. I am just going to create some visual separation so we can see the different parts of the problem. 24 divided by 3 is 8. X to the third divided by x to the third is 1, canceling out, and I have a y. Now, what would I do in that problem? Because I would not work it out that way, and I want you to see some of the flexibility. Because of the way fractions multiply, everything that's in the numerator, like it all becomes combined with like one whole numerator, and the same with the denominator. And what that allows you to do is something called cross canceling. So this x squared will eventually cancel with that x squared. And I would probably do that in my head. And then this x would cancel with that x. And then right here, 6 divided by 3 is 2. And so if you look at what I'm left with the 4. Notice that everything in the denominator is gone. So I have a 4 I have a 2 and I have a y, and 4 times 2 is 8. So that's probably what I would do. Now, I would do a very large portion of that in my head. Not sure I do it all in my head. It might depend on the mood that I'm in, that I could look at that and see, oh, we got a bunch of stuff canceling, and do it all in my head. On a test, I'd probably have some kind of like scratch work. It would probably look something like what I've got here, where I was like canceling out. All right, this one, similar to others, just kind of working through the whole thing here. So I think this one was written to call your attention to the 4 divided by 2, because a lot of students are going to see 4 divided by 2 and say, oh, that's 2. And they're going to see the y to the third over y squared and say, oh, I subtract exponents, that's y to the first power. And kind of miss the fact that we have some exponents going on, okay? And we have to do exponents before we do division. Okay, think of your order of operations, parentheses, exponents. Then you have your multiplication division. So you have to take care of those exponents first. We'll do this one with the law. So we have 4 to the first power raised to the second power, and 1 times 2 is 2. So that's 4 squared. And then 3 times 2 is 6. Down here, I'm going to have 2 to the 1 times 3. So this will be 2 to the third power, and another y to the sixth. And you might right there say, well, I don't have to play around with this anymore. The y to the sixth over y to the sixth is 1. That is the number 1. So that cancels, and you don't have to go any further with it. Now here, you do want to be careful. Same rules apply. Okay, you cannot do 4 divided by 2 because you have exponents there. So we do have to deal with those exponents. 4 squared is 16. 2 to the third is 8, and then 16 divided by 8 is 2. Now, if you had tried to divide it first, then you have the issue of, well, is it to the second power or to the third power? I don't know. So that whole one simplifies to a 2. Moving on. I think this one, I just wanted to make sure that we applied this to a fraction, and I'm aware that the editor put the parentheses kind of weird. We would normally look at it something like that. And for this, you want to remember that, well, you can apply a law here, but to raise something to the third power means to multiply it as a factor that many times. So what we've got here is 2x over x squared times 2x over x squared times 2x over x squared. And now I can multiply my numerators. So 2 times 2 times 2 is 8. X times x is x to the third. And this one comes out differently. And then x squared times x squared times x squared. Well, that would be 2x's, 2x's, and 2x's. And that brings us here. Think to yourself, what do we do here? So now I have x to the third over x to the sixth. Now, if you left it here, that would be understandable. And you might say, okay, well, I can't take away 6 from 3, and so I'm going to leave it. And because we haven't done the next lesson, I would say, all right, fair enough. Now, if you want to apply this, though, you would say that's 8, and then it would be x to the 3 minus 6, which is going to give you -3. If you did this, this is also correct. And you'll have to click on the laws of exponents part 2 to see why and to see what that means. There's also another way you could have done that, and you could have done it this way. You could have said this is 8, and then you've got 3 x's, and then you have 6 x's, and you cancel out those pairs. Okay, and that leaves you with 8, and then in your denominator down here, you have x times x times x, and that is also correct. Okay, on to the next. This next one, I don't know what I was going for with this. I had something in mind. I think just like the string of multiplication going on. Yeah, so this is just 2x to the fifth. We don't need to put those times signs. Now, right here, remember that is going to be 3 to the first power. So we're going to do 3 to the 1 times 4, which is 4. And then we'll have x to the 3 times 4, which is 12. And now we're kind of pushing into, do I want to leave that as an exponent? Like, what do I want to do? But we can do 3 to the 4th power. That's not too bad. 3 to the 4th power would be 3 times 3 times 3 times 3, and that would be 9 times 9, which is 81. So that one's not too bad. And then 2 times 81 is 162. So if you're following the keep it under like 100, then I guess like you would probably leave it with the exponent. But 162, it's really not that bad. And then we have x to the 5th times x to the 12th. So we'll add the exponents and that will give us x to the 17th. And that's a good example of getting into where you don't actually want to expand it out, because I don't think any of us have the time of day or the desire to write out x multiplied in like 12 times. Okay, this seems a bit much. All right. Last couple problems. Now, these ones are going to get into the next video. So these ones are pushing you kind of like that last problem that we looked at where there were all these different right ways to write it, and some of them might have not made sense to you. But looking at number 9, we're dividing like bases, so we know that we would subtract exponents, but 3 minus 3 is 0. And you might think to yourself, well, how can x be used as a factor 0 times? What could that possibly mean? That must be 0, right? Well, over on number 10, we have 2 to the 3rd over 2 to the 3rd. So instead of an x, we actually have a number there. And 2 to the 3rd we know is 8 over 8, and 8 divided by 8 is 1. And I'm going to let you kind of sit with that one a little bit. So if you're going to say that this is equal to 0, then what would happen if x was equal to 2? Well, then it would be equal to 1. So could it really be equal to 0? Let yourself think about it. Be curious. Okay, please don't forget to like this video if you found it helpful. Only takes a second to do that. Subscribe to the channel for more math content, and please drop me a comment or ask a question. Check out the many other videos that we have on the channel, and I hope to see you in a future lesson.